Hello kids, hope you will all be fine. Today in this video I'm going to talk with you about the first chapter of chemistry, that is chemical reaction and equations of class 10th. In this chapter it is an introductory session, so we are going to talk a little about the brief of chemical reactions and equations. So before we start this, let's look around ourselves and understand that what is the need of discussing and talking about or learning about the chemical reactions and equations. So you can see this is an image of an industrial area. You can see this is an image of a quiet village place, and you can see this is an image of a marketplace which is highly crowded and vehicles and everything is there. So you can understand whenever we look around ourselves, there are a lot of activities are going on, and we need to understand the basic nature of these activities. For example, you have to solve any problem related with this all areas, then you need to understand that what is happening in there, what needs to be done to get that thing corrected. So before you find out the problems of any thing, then we need to understand the basic nature of that process or problem, correct? So that is the reason that we need to understand the chemical reactions and equations. So let's talk further. If I have a look at this industrial area or city area with a lot of industry there, you can see in industries a lot of activities will be going on there. If there is a manufacturing industry, for example, fertilizers can be making in that can be manufactured in that industry. If it's a manufacturing of vehicles, then it will also be involving a lot of physical and chemical processes there. Now what in that chemical changes will be required, like some new substances has to be formed, some substances has to be given different shapes, so they has to be melted and given different shape. For example, if you have a look at the car, then you can see there are so many parts in that. So all parts has to be made, and before you make them, the iron and the metal has to be melted and then given different shapes. So you can understand that there are several activities which are going on in all the factories and manufacturing units, correct? And if there are a lot of activities are going on, there are a lot of energy is required, and for working of that factories, electricity needs to be produced, and for producing electricity you need to burn the fuel, and in burning the fuel there will be smoke also produced, and that smoke is, again you can understand, is a new substance which is forming. Whenever the petrol burns or diesel burns or CNG burns, you can understand there is a smoke produced, and that is a new substance which is getting formed from that chemical change or the reaction or the burning process, correct? Let's have a look at the quiet village area. When you look at this, you can understand it's a quiet and not of much activities are going on. But if you have a closer look at this image also, you'll understand there are so many activities which are going on. You can see first in the sky, clouds are moving. If you have a further look at this house, there's a simple house, but there will be so many activities going on. Food will be being prepared, food will be prepared. A lot of activities will be going on. If you have a further look, the grass is growing, the plants are doing photosynthesis, plants are absorbing sunlight and doing photosynthesis. Insects and microorganisms in the soil will be decomposing the organic matter and will be breaking down that organic matter into nutrients, and those nutrients will be used again by plants, correct? So there are a lot of activities which are going on. Even if you look around yourself, you will see so many activities are going on. So we need to understand that either those activities are of physical nature or chemical nature, and in order to understand that, we need to understand that what are the different types of changes which are going on around us. So broadly, we can divide the changes around us into two categories: physical changes and chemical changes. And what is the difference between these two? For example, physical changes involve whenever we give a different shape, like I'm twisting a metal, bending it, giving it different shape. So that type of change, or evaporation of water from water bodies, or condensing it back into clouds. And what is chemical changes involved? It involves changes like rusting of iron, or whenever the food get cooked, that also involve the chemical changes. Now what are those chemical changes and physical changes? Let's have a look at physical changes. Physical changes involve change in shape, size, state of a substance. And what does chemical changes include? They include changes in the how you will understand that there is some chemical change going on. So first it is it can be observed by change in color of a substance, correct? It can be observed by change in the color of a substance, change in the temperature of something. If you are some change is going on where some heat is getting involved or being used up sometimes, so you can understand that some chemical change is going on, not necessarily always, correct? There can be a change in the physical state. Now here there can be new gas forming, or there can be a precipitate. Now what is precipitate? For example, two chemicals are reacting and some solid substance is formed. For example, A and B, both are liquid. When they are reacting together, then some white precipitate is formed, white substance get formed in the test tube, and that settles down at the base. And that precipitate, which is called in short PPT, if that PPT is getting formed, that means a solid substance is forming. So you can understand that some new substance has formed and which has settled down at the base because it is a solid substance. So by that we can understand that there is some chemical change going on, and either it can be evolution of a gas may be forming, so that change will also be a chemical change. Mostly physical changes are reversible, means they can be brought back to the substance. For example, when the water evaporates, water rises up. When the water cools down, again it changes back to water. So these types of physical changes are mostly reversible. But when we talk about chemical changes, these chemical changes are mostly irreversible. That means we cannot change the substance. Once the products are formed or new substances are formed, we cannot change it back into the reactant or the original substances, correct? Remember, there will be some, but mostly these are reversible. Chemical reaction is not involved in physical changes, correct? We are saying that chemical reaction is not involved, fine. And when we talk about the chemical changes, we are saying that in this chemical changes, chemical reaction is involved, correct? We need to understand here chemical reaction is involved, and by the chemical reaction, in physical changes, no new substance will be formed, but in chemical changes, new substances will be formed. In physical changes, new substances are not formed. Only the state of substance changes, the shape changes, size changes, but no new substance is forming. But in chemical changes, new substances are formed, correct? Now when we are talking about that chemical reactions is taking place here in the chemical changes. So what are those chemical reactions? When we talk about chemical reaction, what are those chemical reactions? So we need to understand that chemical reaction is a process, correct? Here reactant or two or more substances which are called as reactant. You can say here, I'm taking example that reactant like A and B, two substances have reacted together and they are forming the product C and D, correct? So whenever some processes get involved, or the process in which two substances react together and they form a new substance, or it can be one substance, it can be two substances which are called as product. So whenever reactants are reacting and products are forming, new substances are forming, that process is called as a chemical reaction, correct? So for example, we can take here example, like you can see here, this is an image, here it is, I'm showing the magnesium is burning, the magnesium ribbon is burning, and in burning of magnesium ribbon, you can see that magnesium, here I have written it is in the form of reaction, like magnesium in the presence of oxygen is on heating, it is getting changed into magnesium oxide, correct? So here you can understand that a new substance is burned. Now how can we say that? When we burn magnesium, then a solid ash like substance is formed, and that ash you can see on the surface. Once the magnesium burns, you can see the ash. So we can understand that here a new substance is getting formed, or the substance original magnesium has changed into something else, correct? Now here I have shown you that reactants as a rule are always written on the left hand side of arrow and products are written on the right hand side of arrow. So we need to take care when we are writing chemical reaction. Now how the chemical reaction is written? Chemical reaction is written as a chemical equation. Here the chemical equation is a representation of a chemical change or a chemical reaction. Now how? In the form of symbols and formulas. Chemical equation is a chemical change is represented as a chemical equation by using symbols and formulas. You can see here I have used the magnesium symbol Mg and oxygen symbol O2 because it's an oxygen gas from the atmosphere which is being used in burning, and the MgO, magnesium oxide, which is forming. So we have only used the symbols here. And you can see one more thing here. You can see here that I have written magnesium is a solid substance which is being used, oxygen is a gas which is being used from the atmosphere, and magnesium oxide, the solid ash which is formed, is also as a solid formed, correct? Now remember here, this is a simple symbolic representation of that chemical change or chemical reaction. Remember, this is called as skeletal chemical reaction or skeletal chemical equation. This is not balanced. You can see here. Now let's talk further about the chemical reaction, how it is represented, then we'll talk about balancing. Whenever we are writing a chemical equation, you can see magnesium, its symbol of magnesium, plus oxygen gas, it should be O2 because it's a oxygen gas, and by that burning of magnesium oxide is getting formed. So you can see here we have written the reactant on left hand side, products on right hand side, correct? Now when we talk about balanced chemical equation, what is this balanced chemical equation, correct? You can understand whenever you talk about balance, that means balance should be there. Just like when we buy vegetables and we see that balance is there or not, correct? So similarly, the chemical equations also needs to be balanced. Now why we need to talk about it, or why we have to balance chemical equation? Because whenever any change is taking place, any chemical reaction is taking place, the mass cannot change. If you have taken a 10 gram of some substance or reactants are 10 gram, then the product can be a new substance, but by mass it should also be 10 gram, correct? The law of conservation of mass says that the mass cannot be created nor destroyed. Mass cannot be created nor destroyed. The things are only changing their form, correct? So in the nature also, whatever the activities are taking place, even the chemical change, here also no new substances are forming. Here only new substances are forming, but their mass remains same. For example, as I said, the mass of reactant, the mass of product will be same. Like I have mentioned here, the reactant's mass and product's mass should be same. So in other words, you can say the number of atoms of elements on reactant side. Now how the mass can be calculated? By the number of atoms, that the number of atoms should be same. So the number of atoms of reactant should be equal to the number of atoms of product. The number of atoms on the reactant side, that on the left hand side, should be equal to the product atoms which is on the right hand side, correct? So I mentioned here, number of atoms on left hand side should be equal to the number of atoms on right hand side. Okay, let's see that what are the steps which are required while balancing a chemical equation. Fine. So first thing we do is we draw the boxes, correct? We draw the boxes around all the reactant and the product, correct? Now second thing, what do? We make a table. Okay, we make a table of one column of elements, one column of atoms on left hand side, and one column on number of atoms on right hand side. So we will see, I'll show you by example also. And what next we need to do, whenever we are balancing a chemical equation, we take an element which is in highest number, the element which is having highest number of atoms, that is taken first to balance. So that means whenever you are balancing a chemical equation, we'll pick an element which is having highest number of atoms, either on the product side or on the reactant side. Fine, so that we have to take care. Second, that whenever we are balancing a chemical equation, we need to take care that we should not change the chemical formula of a substance. For example, MgO. If I need to balance the reaction, I cannot write MgO2, otherwise it become MgO2. So what I do, we use the coefficient. We put the 2 in front of a molecule like 2MgO, not MgO2, correct? So we need to take care that this 2 is used as a coefficient. This 2 is called as coefficient. We are putting it in front of the reactant, outside the bracket. Okay, I'll show you by example also. Second, just like we have balanced the element which is having highest number of atoms, same way we will balance the other elements also. Fine, the number of all the elements on right hand side and left hand side should be equal. Fine. Lastly, we will check all the that all of the numbers are equal or not. Fine. And lastly, we have to take care that we need to mention the physical states of reactant and products as well. How? Because like we have mentioned, a magnesium as a solid, oxygen as a gas, so we need to mention the same here. And one more thing we have to take care that we not just the physical state of a reactant and product, we need to mention the condition required for that reaction to take place also. Like it can involve the heating, it can involve the use of electric current, it can be a change in pressure, change in temperature. So that all condition has to be mentioned. It can be the presence of sunlight, correct? So that all conditions has to be mentioned either below the arrow or above the arrow. So you can put those conditions on either side of the arrow, correct? So take care about it. Just I have taken one example for you here. Like if the iron is getting reacted with the water and Fe3O4 is being made and hydrogen gas is evolved, how is this reaction a balanced reaction? Here the number of iron are 1. Here the number of iron atoms is 3. It is 1 on left hand side, 3 on right hand side. It is 1 oxygen here, it is 4 oxygen here. So that means it is not a balanced chemical equation. This is the simply skeletal chemical equation. Fine. So we need to balance it because in order to fulfill the law of conservation of mass. And we know that new thing cannot be made when a chemical reaction is new thing means the new product will be formed, but new atoms or things cannot be created. In nuclear reactions, that is a different thing. When a nuclear fission or fusion is taking place, that's a different. But in general or normal chemical reactions, the number of atoms of different elements will remain same on reactant and product side. Now let's see, as I told you, first the substance which is having highest number of atoms, it has to be taken for balancing. So here you can see the number of oxygen is highest, it is 4. So we will take oxygen first for balancing, correct? So what we have done, so to balance oxygen here, we have put the 4 coefficient here in the second step. So by putting 4 as a 4 coefficient, we have equal the number of oxygen. So it is now oxygen has got balance. It is on 4 on left hand side and it has become 4 on right hand side as well. Now next thing what has become more is the number of hydrogen atoms. Now it is 4 into 2, that means hydrogen has become 8. So now let's balance hydrogen first. So for balancing that, we have put 4 as a coefficient on the right hand side. So now the number of hydrogen atoms, 4 into 2, 8 and 4 into 2, 8. That means hydrogen atom is also balanced now. Fine. So the number of atoms will be 8 on both the sides of the reaction. Now the next thing we have to balance is the last atom, that is iron. Okay, so here number iron in the beginning was 1 atom, and on this side we were having 3 iron atoms. So we have put 3 in front, 3 as a coefficient in front of iron, and it has become, now both the sides the reaction is balanced. So it is 3 and it is also 3. Okay, so this way that this reaction is balanced. Now in the last step we'll check that every number of atom is 3. Here it is 3. Number of atoms 4 into 2, 8. 4 into 2, 8. Now, and oxygen 4, and here it is also 4. So this we will check the number of atoms of all the elements on both the sides of reaction. And last we have to see, as I told you, discussed with you earlier, that we have to mention the physical state of a substance, correct? That solid, because iron is solid, and water which is reacting here is the one which is in vapor form. That means the iron is getting reacted with the vapor form, that is the water vapors which are present in the air, or we are creating a steam or water vapors to make it react with the iron. So here that's why we have mentioned that the gaseous form of water is reacting, and the iron oxide Fe3O4 which is forming is in solid state, and the hydrogen it is evolved is a gas. So we have mentioned physical state of all the substances, correct? And if any condition would have been there, we'll write the condition on the left hand above the arrow or below the arrow. Fine. And thank you for watching. Add achievers, if you like it, share it, subscribe it. If you have any question, you can leave it in comments. Thanks for watching. Take care, beta.